two projects. In this video, we are going to explain about the project, which is tomato quality classification based on transfer learning feature extraction and machine learning algorithm classifiers. Before getting into the execution, first, let us understand what is the project about. When it comes to tomatoes, they are undoubtedly one of the most widely consumed vegetables across the globe. In fact, in 2021, production levels hit an impressive 189 million tons of the tomatoes, highlighting their importance in our diets and the food industry. Ensuring the quality of these tomatoes is very important. That's where the sorting and grading comes into the picture. So, coming to the grading is all about categorizing tomatoes based on various criteria, including size, shape, ripeness, and surface defects like cracks, sunburn, insect damage, and blossom end rot. But the traditional methods that we have for grading these tomatoes is manual grading, and it has some downsides. It can be very labor intensive and also time consuming. Moreover, because it relies on human experts, there are always a risk of inconsistencies creeping in. Factors like fatigue and subjective judgment can lead to errors, making it less reliable for maintaining quality standards. So here where machine learning comes into the play. Machine learning, it really offers a great alternative to the traditional methods of grading tomatoes by automating the grading process, and it not only cuts down on labor but also boosts the accuracy, which is essential for agricultural sector. Now we look at traditional learning models, that is machine learning models. They require manual feature extraction, which can be a bit hassle. On the other hand, deep learning models like CNNs, that is convolutional neural network, can automate this feature extraction. But they do have their downsides. Specifically, they can take longer time to train and require more computational power. So finding the efficient solutions is key, which need systems that can handle the large volumes of tomatoes being produced without sacrificing speed or accuracy. This is crucial for agricultural industry to meet market demands while also ensuring that the quality standards are upheld. So moving on to overcome all these limitations, in this project we are introducing a hybrid approach to sort and grade the quality of tomatoes. What that means is we are combining deep learning and traditional models in this project. So we are combining deep learning and traditional machine learning models to get the best of both the worlds. So here we use pre-trained convolutional neural network for feature extraction. So we will be using pre-trained models for extracting the features, and then we will be employing basic machine learning models. So this by employing this pre-trained CNNs helps us to identify important characteristics of the tomatoes in the images. Then for the actual classification here, that is whether a tomato is ripe, unripe or damaged, we are introducing some traditional machine learning models which are support vector machine, random forest, k nearest neighbors and the other classification models. So these methods, they can accurately sort and also grade the process more, making efficient and accurate. To classify the tomatoes, we need to train the models, right? To train the models, we need basic images that are tomato images. So we have taken the tomato image data set from the Kaggle repository, which is a great resource for open source data. So this data set, it was created using NVIDIA Jetson TX1. It's a single broad computer that's quite powerful for image processing tasks. And to get the most out of images, we have applied some image pre-processing techniques and we have fine-tuned the layers of the CNN. So this step is crucial because it helps the models to concentrate on learning the complex and important features of the tomatoes. For feature extraction, we have opted Inception V3, which is a well-known CNN architecture that is effective in capturing those features. Once we extracted the features from the images, we used traditional classifiers that are support vector machine, random forest, KNN to sort the tomatoes into categories such as healthy, ripe, unripe, or damaged. This will allow us to enhance the accuracy of our sorting and grading process. As an extension to this project, to further improve the accuracy, we have incorporated some algorithms. So, exception is the advanced version of the CNN. So, this exception model is used for extracting the features, and that is integrated with the voting classifier to classify the tomato quality. And this model has achieved the best performance. So this combination has performed exceptionally well, achieving the better accuracy than any of the other models we tested when categorizing the dataset based on the features we extracted. Looking ahead, we have created the front end using Flask framework. So we created the front end using Flask framework. So this app will make it easier for users to interact with our model, and it will include user authentication for added security purpose. Our goal is to provide an accessible interface that enhances the user experiences, allowing stakeholders to test and evaluate the tomato quality grading system in a practical way. This way, they can see the first and how effective our solution is in the context. Moving on to the implementation of the project, we have followed the steps in the flow of work. So, what we have done is first we have imported the required packages. So, we started by importing the necessary libraries and packages that we need for our project. Then we have imported the dataset, that is two class tomato leaf data, tomatoes dataset and three class tomato dataset. This involves looking at the dataset which have containing images of tomatoes. We categorize these images into two classes, that is like healthy and rejected, and the other classes unripe, ripe, and rejected. Moving on to the image processing. So in this step is about preparing the images for analysis using various techniques. So we have applied image data generator. So we apply several transformations to enhance the images. We adjust pixel values by using this rescaling technique. So we adjust the pixel values to between 0 and 1. Then we do shear transformation. It is slightly slanting the images to create a variety of images. Coming to zooming the image, here we zoom in on the images to add different perspectives. Coming to respective horizontal flip, it's a flipping the images horizontally for the variation. Next, we reshape the image. It is adjusting the dimensions of the image as needed. The next step we do is feature extraction using this CNN and HOG models. So this involves multiple things, that is reading the image. So we load the images into the program and then we resize them. We convert the colors, that is we change the color format if necessary, and then we append all the images and labels. That means we organize the images with the corresponding labels. And then we convert all those images into the NumPy format, and then we convert those labels into numerical values for processing purpose. Then we create multiple machine learning models using the process data. Then we train the data set. Then we train the models using the data set so that it learns to reorganize the patterns in the images. Then we dump the model to, I mean, we will be saving the train model to a file so we can use it later without retraining. And then we have built Flask framework using we have built front end using Flask framework, which is integrated with the SQLite 3 database. And then in the front end, users they will be able to upload the tomato images, and those images will be pre-processed at the backend. So those images will be pre-processed at the backend, and the dumped model, that is the trained model, will be used for predicting the quality of the tomato, and we will be displayed with the final outcome in the front end. So final outcome will be displayed in the front end. Moving on to the algorithms used. So coming to the algorithms used, we have used multiple deep learning models for extracting the features that are pre-trained models, and for classifying the tomato quality, we have used machine learning models. So coming to feature extraction, we have used ResNet 50, MobileNet V2, Inception V3, AlexNet, CNN, and the extension model Exception. So all these are used to extract the important features from the data set, that is from the tomato images. And then we have used support vector machine, random forest, k nearest neighbor, and the extension voting classifier model to classify the tomato quality. So after extracting the features from ResNet 50, we will be training all these algorithms to predict the tomato quality. So similarly, after extracting the features from MobileNet V2 by using the MobileNet V2 from the images, then we will be training all the algorithms. In the same way, for Inception V3, AlexNet V2, AlexNet CNN, extension, exception. So after extracting all the features, then we will be training all those models individually for all the feature extraction techniques. Moving on to the requirements to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now to execute, we need to open the code folder which contains source code files. So let's open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in the project? In the sample folder, we will be having the images that are test cases that we will be using in the front end to predict the tomato quality. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files. And those are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. And in the three classes folder, we have subfolders which are used to train the model. So all these are the images that are used to train the model to predict the tomato quality in three grades. So here we have three grades. One is rejected, ripe, and unripe. For suppose if we take the reject folder, we have images of tomatoes that will be rejected. So these are the tomatoes that will be rejected. So these images we will be training the model to reject the tomato. Get back. Coming to ripe folder. So these are the ripe tomato images that we will be using models to train the tomato images to predict as ripe. Moving on, here we have the unripe tomato images. So these images are subdivided into train and valid, where train in the train folder we will be having set of images. So these three folders we will be using for training the model, and the validation folder, I mean in the images which are in the validation folder, we will be using to test the model. Get back. Similarly, in the two classes also we have the images. So here we have two classes which is reject and healthy. In the healthy folder, we will be having the images of tomatoes which are healthy. We will be training the algorithms to predict the tomato as healthy. And here we have the rejected images of tomato. Get back. Similarly, in the output folder, those images are combined and split it into train and validation, where train is used to train the model and validation is used to evaluate the model. Get back. And here we have the model file. So these all are the model files. These algorithms, I mean, these models contain the algorithm information and that will be loaded into the project code during the runtime of the application. So these are all the model files, which are in the format of .hy, sav, numpy, etc. And coming to this app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And we have two notebook files. One is 3 class and the other one is 2 class. So these are the Jupyter notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And coming to this sign up file, that is the signup.db file, this file is a database file which is used to store the user information. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. So by this command, current directory will change to the code folders path. So here if you observe, current directory is changed to the code folders path. Now compile app.py file by giving the command python space app.py and now click on enter. This command, it will execute the Python script and perform a runtime checks for any syntax errors or logical issues. And after running the app.py file, Flask framework, it will host the application locally at the default address, which will be the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is developed using Flask framework. So we need to sign in first, click on sign up and enter all the registration details if you are signing up newly. I have already signed up, so I'll directly sign in. So click on sign in, give your username and the password. Click on sign in. We have signed in successfully and we are redirected to prediction page of the project. As we're doing classification for 2 class quality and 3 class quality, so first we will be doing quality of tomato of 2 classes. So click on 2 class. So here you can see a choose file button, right? We need to click on that for uploading the tomato images. So click on choose file. We have test cases in the sample folder. As we are doing prediction for the two class, open two class folder. Let's upload the images in the healthy folder and check whether the application will correctly predict that the image is healthy or not, that the tomato is healthy or not. Let's upload the first image. Click on open. Here we can observe that image is loaded. Now click on upload. After image being pre-processed at the backend, the dumped model, it will give the prediction. So this is the uploaded image, and here we got the prediction correctly that it is a healthy tomato. Let's try using one more image. Click on to class, click on choose file. Let's try with this image. Click on open and now upload, and now click on upload. So here we got the prediction. This is the uploaded image, and here it has correctly predicted that it is a healthy tomato. Let's try with the other case. Click on to class, click on choose file. Let's try with the rejected case. Let's upload this and check whether the application it will correctly predict as rejected tomato or not. So let's upload it. So this is the image uploaded, and here we got the correct prediction that the tomato is rejected. That means it belongs to the grade of rejected. Let's try one more with one more image. Click on choose file. Let's try with this image. Click on open and now click on upload. So this is the uploaded image, and here we got the prediction as rejected tomato. It means that tomato is not good. Let's try with the other prediction, that is three class prediction. So click on three class. Now we will be doing the prediction for three classes. So click on choose file. Open the three class folder. So let's try for the first folder, that is reject. Let's upload the first image. Click on open. So image has been loaded. Now click on upload. So this is the uploaded image, and here we got the prediction as rejected tomato. Let's try with the one more image. Click on three class. Click on choose file. So let's upload this image. Click on open and now click on upload. So this is the uploaded image, and here we got the correct prediction that rejected tomato. Now let's try with the one more case. Click on three class. Click on choose file. Let's try with the ripe case. So these are the ripe tomatoes. Let's try and see whether the application will correctly predict that tomato is ripe or not. So let's upload it. Click on open. It has been loaded. Now upload it. So this is the tomato image, and here it has correctly predicted as ripe tomato. Now let's try with the one more image. Click on choose file. Let's try with this image. Click on open and now click on upload. And here we got the correct prediction that it is a ripe tomato. Let's try with the last case. Let's try with this unripe case. So these are the unripe tomatoes. Let's upload this image. So this is the unripe tomato that we have uploaded, and here it has correctly predicted that it is an unripe tomato. Let's try with one more image. Let's try uploading this image. So this is the image that we have uploaded, and here it has correctly predicted that it is an unripe tomato. By this way, by uploading the tomato images to the application, it will correctly predict whether it is ripe, unripe, or healthy or rejected tomato. Now let's check with the graphs. So let's check graphs for the two class. So click on two class. So here we have models evaluated for the two class prediction, where the models are trained to predict the tomato quality for two class. So this is the accuracy graph, which is used to evaluate all the models built. Here on x-axis, we have the accuracy scores, and on y-axis, algorithm names. On y-axis, we have the algorithm names. If you observe, exception is having the highest accuracy. And this is the precision score comparison graph. This is the recall score, and this is the FN score. Here we have specificity. This is before feature extraction. And here we have after feature extraction. So this is the graph. This is the accuracy graph after extracting features from the transfer learning models and training the machine learning models to predict the tomato quality. Here on x-axis, we have accuracy score, and on y-axis, we have the algorithm names. And here we have precision score. This is recall score that we have. This is FN score, specificity. That's all. Now let's check with the other prediction, that is three class prediction. So click on three class prediction. So here we have trained the transfer learning models to predict the tomato class, that is tomato quality. So this is the accuracy score, precision, recall, and FN score, specificity. And here we have for three class prediction, I mean, we have extracted the tomato images using, we have extracted the important features from the tomato images using the transfer learning models. And then we have trained using machine learning models to predict the tomatoes of three classes, that is healthy, ripe, unripe, and rejected. So here on x-axis we have accuracy and on y-axis we have the algorithm names. If you observe the extension model, which is exception with the voting classifier, is having the highest accuracy. And this is the precision score comparison graph. This is recall score, FN score, specificity. So now click on sign out. In this way, by extracting the features using transfer learning models and training them with the machine learning models to predict the quality of the tomatoes, this will help all the farmers to accurately classify the tomato quality. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.